Hello, and welcome to the Tentative Tutor channel. Here's an interesting one. For what integers n does n divide 2 to the n minus 1? If you'd like to pause the video and think about it, I'll solve this problem in 3, 2, 1. Let's try out some examples, starting with n equal to 3. Does 3 divide 2 cubed minus 1? Let's give it a try. 2 cubed minus 1 is 8 minus 1, which is 7. But 3 doesn't divide 7, so that doesn't work. But what about the other numbers? Could there be any other that work? Actually, there are very few numbers that will satisfy this equation. Let's make a few more attempts, starting with 0. 2 to the 0 minus 1 is 1 minus 1, which is 0. And 0 divides 0, so that works. How about 1? 2 to the first minus 1 is 2 minus 1, which is 1. And 1 divides 1, so that works. Next, let's try 2. 2 squared minus 1 is 3, but 2 does not divide 3. We already tried n equal to 3. Let's try 4. We see that 4 does not divide 15, so that also does not work. Notice that if n divides 2 to the n minus 1, n must be odd because 2 to the n minus 1 is odd. Let's try a larger odd number. How about 35? Does 35 divide 2 to the 35 minus 1? Let's give it a try and see if we arrive at a contradiction. Let's take the smallest prime that divides 35, which is 5. Notice that since 5 divides 35, it must divide our number 2 to the 35 minus 1. In other words, 2 to the 35 is congruent to 1 mod 5, meaning 2 to the 35 on division by 5 leaves a remainder of 1. But we know from Fermat's little theorem that 2 to the 4th is congruent to 1 mod 5, where here 5 is p and 2 is a. That is, 5 divides 2 to the 4th minus 1. 4 is in fact the order of 2 mod 5. It's the smallest power of 2 that reaches 1 mod 5. And in fact, any other power of 2 that reaches 1 mod 5 would have to be a multiple of 4, meaning that 35 would have to be a multiple of 4. But 5 is the smallest non-trivial factor of 35, and that's a contradiction. Let's try n equal to 77. Suppose once again that 77 divides 2 to the 77 minus 1. And we'll also take the smallest prime that divides 77, and that's 7. Since 7 divides 77, 7 must also divide our number 2 to the 77 minus 1, meaning 2 to the 77 is congruent to 1 mod 7. But we know from Fermat's little theorem that 2 to the 6 is congruent to 1 mod 7. In other words, 7 divides 2 to the 6 minus 1. In this case, 3 is in fact the order of 2 mod 7. That is, it's the smallest power of 2 that reaches 1 mod 7. Since 2 cubed is congruent to 1 mod 7. But once again, that would mean that 77 would have to be a multiple of 3. And since 7 is actually the smallest non-trivial factor of 77, that's a contradiction. So this suggests how we might prove this in general, that is impossible for most integers. Spoiler alert, proof upcoming. Yes, we're about to do some real mathematics. We're going to prove this result by a proof by contradiction, meaning we're going to assume it's not true, assume the negation of our hypothesis, and arrive at a contradiction. Buckle up because you're about to see some real mathematics. Now let's prove our result is impossible for any integer greater than 2, meaning greater than or equal to 3. Let's let n be an integer greater than 2, and assume that n divides 2 to the n minus 1. Of course, that means 2 to the n is congruent to 1 mod n. Let's let p be the smallest prime divisor of n. Since n is odd, p must be odd, and p is greater than or equal to 3. Since p divides n, p must also divide 2 to the n minus 1. That is, 2 to the n is congruent to 1 mod p, just as we did in the examples. But by Fermat's little theorem, 2 to the p minus 1 is congruent to 1 mod p. So we have both 2 to the p minus 1 and 2 to the n congruent to 1 mod p. Let's let r be the order of 2 mod p. That is, r is the smallest positive integer for which 2 to the r is congruent to 1 mod p. But then r must divide both n and p minus 1. So r is a non-trivial factor of n that's smaller than p minus 1. But p is the smallest factor of n, so that's a contradiction. Since we assumed the negation of our result and arrived at a contradiction, that means our result must be true, and that's how one accomplishes a proof by contradiction. I hope you enjoyed it. Now here's our bonus problem. Be careful, this isn't for the faint of heart. Find all integer solutions for which x squared plus 1 is y cubed. Leave your answer in the comments and try to do it without AI. Thanks for watching.